All right, hello and welcome back. My name is Cameron Kirk, and this is video number 3 on my series for the DE10-Nano projects. In our last video, we built Debian Linux from scratch, and we put that on an SD card and booted it on the board. And in this video, we are going to be doing a walkthrough on how to flash the FPGA from the onboard ARM processor, the HPS, from within our Linux environment. So if you did not follow along in the last video we did a sort of walkthrough on the steps shown here in this repository. Link in the description for this repo if you haven't been here yet. Super recommend. There is tons of great information on this repo and the wiki pages. If you did not do the last video and you don't want to do the last video, you just want to jump in with this video focusing on developing that FPGA from a Linux environment all on that board. What you can do is if you head over to the releases page, you can just get the images for the different distros on here. So they have Debian, and yeah, you can just download that image and use Rufus to flash it to an SD card or your SD card and plug that into the board and boot that up. Okay, so hopefully that works for you. We should all be ready to go. I am going to start out with booting up the board. So I have an Ethernet cable connected to my board, and I am going to connect a USB cable to the UART to USB port, and that is going to be on the same side as the Ethernet port. So we'll just go ahead and plug that in. And before I supply power, it's not necessary to do this, but I am going to open up PuTTY. I'm going to switch to serial mode. I'm going to change the baud rate to 115200. Baud rate is the speed of communication on the UART USB wire. And we are also going to open up Device Manager. If you right-click on your Windows icon or search for it, you need to get Device Manager opened up, and this will tell you where your the port or the COM port for your board. So we're on COM 3. So if we go back to PuTTY and we change this to COM 3, we're good to go. We'll click open, and that is ready. So what I'm going to do now is I am going to supply power to the board. So power right here. And before I do it, let's change this font size. I'm going to change settings just to make the font size a little bit larger. I'm going to go for 14. Click OK, apply. And I'm going to plug in power to the board. And I also have my fan on, because this board does heat up when it's using the ARM processor. Cool. So while that goes, today's project is pretty straightforward. Please do make sure you have the dip switches in this configuration before continuing. It's fine if you flip these switches while the board is already powered on. I tested that and that worked for me. Just make sure those are all flipped on. And then we're going to take this Verilog code. It's pretty straightforward. They are implementing a counter. And it's going to count up every time the clock, which is a very fast clock, every time that clock ticks, it is going to count up. And then we're using the very last bit, so the most significant bit. So that's going to be the bit that changes the slowest. And that is all this module does. So it's a pretty simple blinky module, nothing too exciting. But we're going to stick with it for this, this walkthrough. And it would be very interesting to, take previous designs in the Verilog development tutorial. If you haven't checked that out, the link is in the description. I have a series on programming in Verilog, putting some of those projects and some of those designs on the FPGA through the ARM processor would be interesting to see. One of the big motivations I have for, I'm going to click on new project. I'm going to just sort of walk through setting up a new project here. Let me get to a good folder. DE10-Nano live demos. Go to Quartus project. I'm going to call this Blink Live. I'm just picking a folder for where to put all these files. So I'm going to call it Blink Live Select. And the name of this project is Blink. Click Next, click Next, click Next. So we're going to do SE base, scroll all the way to the bottom. U23i7, click Next, click Next, click Finish. So one of the big motivations for doing this project is if you take a look at the board here, there is not a lot of built-in I/O. So I have a video on connecting a 7-segment display to this device, but that's just one digit that shows up. There are 8 LEDs underneath this fan. There's 8 LEDs, and you have 4 switches and 2 buttons. So like one video I wanted to make, let me get back to work here while I'm talking. One video that I wanted to make was, I'm going to click New, Verilog. I wanted to do an ALU for my next video. I wanted to show how easy it is to make an ALU in Verilog. But unfortunately, there is not enough I/O built into the board to actually use the ALU. So I think the way we're going to have to go is we can implement the ALU, but we're going to have to write a C program to get the input and get the output for this custom ALU. And then we could make the ALU really crazy and like super high performance, and we can make it do really custom instructions, whatever we want to do, but we're going to have to control it from a C program, and we're going to use the C program to print out the results from our ALU and send in our operands to the ALU. If we were to use like the DE2, something like this, you'll notice there is just so much more built-in I/O. We have all of these 7-segment displays. Look at all those switches. Look at the push buttons. There is just so much on here. But unfortunately, that's not what we're using in this video series. So we're going to have to use Linux and use a C program to get our input and output, and that's going to be the way to go. Okay, so we need to do our pin assignments. Let's go to the pin planner. Let's get our handy dandy, we need our schematics. There we go. We need to assign the LED to a pin. So I'm going to put mine on LED 0, which is W15. W15, push enter. We need to get the clock as well. Now, I don't remember where the clock is on these pages. Clock, FPGA. Oh, wait, what about V11? Yeah, let's do V11. Okay, there we go. That's not V11. 8 V11. Why can't I assign V11 to this? There we go. V11. Okay. And I believe we are good, so we can close this down. We can go back into Quartus, and we can do our compilation. And I'm going to pause the recording while this compiles. Okay, we are back. And if we take a look at the instructions back on the wiki, Yeah, it wants us to generate the SOF file, and that is what we just did. And then now we're going to make the RBF file. So to do that, we are going to go up to File, Convert Programming Files. We are going to output to an RBF, raw binary file. The file name, let's call it blinky. And select on SOF data, click Add File. Output file is SOF. And then click Generate. And it worked. So now, if we look in the project files for this project, I could just figure out where I'm going. Blink Live. We have this RBF right here. So the next thing we need to do is send it over the network to our board. So just to touch on this for a second, I have my DE10-Nano plugged in on the Ethernet port here, and it is connected on my network. I did spend a lot of time trying to figure out how to do a file transfer just over this serial port, and I was never able to get it to work. I'm going to continue looking into that. I don't know if it's possible. I tried a lot of things, and I just couldn't get it to work because, this thing's a little bit inconvenient if you have to have it wired into an Ethernet port. Yeah, so I may make a follow-up video in the future showing how to do this file transfer just over the serial connection. But anyways, that's just a little bit off topic. We're going to copy this command here. We're going to go to the directory or the folder containing our RBF, and we're going to hold down Shift and right-click and click PowerShell. All right, so we're going to do, you should have SCP, so if you type SCP and push Enter, it should tell you that. Let me see here. I just want to make that font size a little bit larger. I guess 16 is good. Okay. Clear. All right, SCP, and then we're going to type in blink. Now we want blinky RBF, and we are going to send it to root at, and this is the big question. How do you get the IP address? So if we switch over to PuTTY, which remember has our serial connection to the board, I'm going to sign into root here, and remember we set that password to root. And then if we do an if config, we get our handy dandy IP address right here. I'm going to copy that with Control-Shift-C. I'm going to paste it here, and then we do a colon, and then we have to specify a directory we would like to send this to. In the example, they send it to the home directory, so they do a tilde, push enter. Once the password, say root, and off it goes. It just sent that data. So now when I come back over to PuTTY, I am currently in the home directory for root, and if I do an ls, now I have this blinky RBF. I have another one here, but just ignore that. That was from playing around with this earlier. Okay, so we're going to create a device tree overlay, moving right along here. So to flash, and I do recommend you read through this. I'm not going to read through it right now, but we're just going to keep moving along here. So we need to create in the root folder this file called blink.dtso. So I'm going to say vim blink. I'm going to call mine blinky dtso, push enter. I'm going to push I for insert. I'm going to copy this text and right click and paste it in there. Push escape, push colon, WQ, enter, and that saved it. So now we have that file. In our case, the binary file, mine's called blinky. So let me jump back in to there. And I just need to change mine to say blinky. I for insert, Y, enter, escape, colon, WQ. There we go. clear ls. Okay, we're ready to go. So now we need to get this device tree compiler. I definitely already have this installed. So it's just going to say up to date. But if you don't have it, go ahead and install it. And we need to run this command to compile. But mine is called blinky. So I'm going to put a Y on these, push enter. And that worked. So now we have all of these files here. And we need to copy the DTBO and the RBF to the folder lib firmware. Now, I already have lib firmware existing. And there's some stuff in there already, but that's fine. We're going to copy in our new stuff. So cp blinky DTBO. We're going to send that to lib/firmware. Okay. And then we're going to send the RBF as well. Now we're going to make a mount point and mount our configfs, which gives us access to the device tree. So let's make a config folder. Now if I ls/. So we have this config folder. If I do an ls on /config, if I do an ls on /config, there is nothing in that directory. So there's nothing in there. And then we're going to mount configfs to that mount point. So let's run this command. And then when we look inside config, now there is a device tree inside there. So they do a command like this, and that lets you see, oh, I forgot to copy the L. I'll let you see everything that's inside. Cool. So now we're going to create a new folder in the device tree. Okay, so we are in the device trees overlay folder. We need to create a blink directory. I'm going to call mine blinky just to stay consistent. And now inside that blinky folder should have some things in there. And we are going to type in the characters of our DTBO file. Oh, but it's called blinky. So I need to change that to a Y. And oh, and this is also called blinky. Sorry. Okay. And it is now running our design. So if I switch over to the tabletop here, and I sort of tilt this guy up, you can see that our LED is blinking. Very cool. And that is the end of this walkthrough. Let's see here. The final thing it says here is, up to the design, you just have to remove your blink folder from the device tree overlay. And then follow the steps again to flash a new design. Cool. So thank you so much for watching. I hope you learned something in this video. In the next video, we are going to be looking at how to flash the FPGA on boot, and then hopefully we can start getting into something interesting. I do want to do the walkthrough for their simple hardware adder, and then I want to use what we learned in the simple hardware adder tutorial to actually implement a custom ALU in the FPGA that you can interface with from a C program. That would be very cool to see. So, all right, I will see you in the next one. Take care. Bye-bye.